All right, guys, back for another go around. Okay, remember again, we're working off of a lot of information off of this sheet, so certainly keep that guy close by. Okay, also remember that this unit circle comes into play, okay, on a regular basis. Okay, so keep that close by. Okay, remember we talked about these reciprocal identities and quotient identities yesterday. Okay, remember that those identities are also on this main sheet, okay, right up here towards the top. Okay, so we have those. Okay, now we're going to be taking a look at these Pythagorean identities right here, and these guys can also be found, okay, up top on this sheet as well. Okay, these guys are about as important as it gets. They come up over and over and over again, okay, in mathematics. So you definitely want to make sure, okay, that you remember these off the top of your head, especially the top one, okay, especially sine squared plus cosine squared equals 1. Okay, the other two, the second one down and the third one down, are just derived from this top one. So we're going to derive all these guys today, okay, and this is relatively easy to do. Okay, so starting with the top one, sine squared plus cosine squared equals 1. Okay, the easiest way to do this, okay, is on the unit circle. Okay, so if I take any point on the unit circle, okay, and I'm just going to work in quadrant 1 because it's easy. Okay, and so I take this point right here. Okay, and so that is some point P. Okay, and obviously it's some coordinates X, Y. Okay, so if I drop a vertical line down, okay, to form a right angle, and then draw the radius, okay, to that point. Okay, now for instance, we know the radius is 1 because we're on the unit circle. Okay, and so I've got my theta in here, my angle of rotation. Okay, and we know that we have our X here, whatever it is, and we have our Y here, whatever it is. Okay, all right, so we take a look there and we say, okay, well, what's going on? Okay, well, we're on the unit circle. Okay, so I know that every point, okay, on that unit circle has coordinates cosine theta, sine theta. Okay, and that's going back to our unit circle. Okay, so for instance, if we went back here on our unit circle and I was working at 30 degrees, I know the cosine of 30 degrees is radical 3 over 2, and I know that the sine of 30 degrees is 1/2. Same thing here if we were at 90 degrees. I know the cosine of 90 degrees is 0, and I know the sine of 90 degrees is 1. Okay, so this point xy, okay, we know that would also be, okay, cosine theta, sine theta. Okay, so my x coordinate would be cosine theta, and my y coordinate would be sine theta. And so all I have to do is apply the Pythagorean theorem. Okay, remember Pythagorean theorem, and I know you guys remember this off the top of your head. We're going to get leg squared plus leg squared equals the hypotenuse squared. Okay, so if I just take leg squared, so sine theta squared plus leg squared cosine theta squared equals the hypotenuse squared, which is 1 squared. Okay, now when you do that, sorry guys, there was some noise out in the hallway. Okay, in trigonometry and higher math, we usually, when we square a trigonometric function, we usually put that squared between the sine and the angle neg. So saying the second power of sine squared, that's the same as saying sine squared theta. It means the same thing. Okay, plus do the same thing here. Rather than saying the second power of cosine theta, we write that as cosine squared theta equals, obviously 1 squared is 1, and there you have it. Okay, you have your sine squared plus cosine squared, okay, is equal to 1. Okay, it's going to happen 100% of the time. Okay, you could even go back to, the unit circle, for instance, and you could verify that that's going to happen. Okay, you could pick, anywhere you want to go. It doesn't make any difference. Okay, so let's suppose, I don't know, I'll just stay in quadrant 1 because it's so easy to work with, and let's suppose we go with 45 degrees. Okay, and so if I let theta equal 45 degrees, okay, which obviously is the same as pi over 4, it doesn't make any difference, and I say sine squared of 45 pesos plus cosine squared of 45 pesos, that has to give me 1. Okay, so what's the sine of 45? Well, the sine of 45 is radical 2 over 2. Okay, so I get radical 2 over 2 squared plus cosine squared of 45 degrees. Well, cosine is also radical 2 over 2, so we would go radical 2 over 2 squared, and that has to be equal to 1. And so if I square this, notice I'm going to get 2 fourths. If I square this, I'm going to get 2 fourths. And obviously 2 fourths plus 2 fourths is 4 fourths. That's going to happen everywhere on the unit circle. Okay, and it doesn't matter. If you don't believe me, you can more than welcome to take some random values off the unit circle and verify them, and it'll come out to 1 every single time. Okay, so this guy's really important. Okay, really important. Okay, so let's see. We got that first guy done. Okay, and now we want to verify this guy. Okay, so if we take tangent of theta and square it and add 1, we're going to get secant theta squared. Okay, so let's see. As I told you, okay, this is derived from this, okay, all the way through. Okay, so if I take this sine squared theta plus cosine squared theta, okay, equal to 1, okay, and I'm pretty sure this one I would have to divide everything by cosine squared. Okay, so if I divide by cosine squared theta, and cosine squared theta equals 1 over, well, let's see, let's just do this, 1 over cosine squared theta. Okay, so this sine squared theta over cosine squared theta, remember that's the same thing as the second power of sine theta over cosine theta. Okay, obviously cosine theta over cosine theta is just 1. And let's see, this guy would be the same as 1 over cosine of theta squared. Okay, so sine theta over cosine theta, going back to your tangent and cotangent identities, we know sine over cosine is tangent. So this is the same as tangent theta squared plus 1. And let's see, the reciprocal of cosine is the secant. So that'd be the same as secant of theta squared. And obviously we would write this as tangent squared theta plus 1, and we would write that as secant squared theta. Okay? So there you go. Okay? So you have your second Pythagorean, okay, identity. Okay? Now we want to take a look at this guy. And again, okay, you're going to start with your first Pythagorean identity, sine squared theta plus cosine squared theta equals that equals 1. My fault. I'm copying down this from up above, which I shouldn't be doing. Okay, so if I divide everything by sine squared, okay, so divide here by sine squared theta, divide here by sine squared theta, and divide there by sine squared theta. Okay, again, we know sine squared theta over sine squared theta, that's just 1. Okay, now remember, this right here is the same as the second power of cosine of theta over sine of theta. And this guy would be the second power of 1 over sine of theta. Okay, so cosine over sine, okay, that's cotangent. Cotangent theta squared, bring down your plus 1, equals, let's see, 1 over sine. Well, the reciprocal of sine is cosecant, so that would be the cosecant of theta squared. And obviously we would write that as cotangent squared of theta plus 1 equals cosecant squared of theta. And you have your last Pythagorean identity. And there is more noise out in the hallway. Okay, so that's some pretty easy stuff. Okay, but these guys right here are really, really important. Okay, they come up over and over and over again in higher mathematics. Okay, so you got to be able to remember these guys off the top of your head. Okay, I know, especially the top one. Okay, this guy comes up, I mean, I can't tell you, I see it all the time in trigonometry, and you see it constantly in calculus as well. And if any of you guys go on to study something math related, okay, in college, you'll see it in a number of different classes. Okay, these two you don't see as often, okay, but all three of them are really important. Okay, that'll wrap it up for today. And you guys make sure you stay safe out there. And your quiz grades from last week are posted, so you can check those. Stay safe, and I miss all you guys.